Wonderful. Welcome, everyone. Very exciting to see a full room. Excited to be kicking off the Agentic AI in Practice panel. So my name is Ryan Kearns. I'm a doctoral researcher here at the Oxford Internet Institute, same as Cassidy. And I do work on the evaluation of AI agents for my PhD. But I'll be excited to punt it off to this panel of experts to be digging into all things Agentic AI. So I'll want to do maybe 40 to 45 minutes of structured questions, and then I want to open it up to the audience as soon as we can to have you all chime in. But I think briefly, just to kick us off, why don't we do a round of intros, and then I'll start with some questions. So maybe starting with Nicole, if you want to give a brief introduction.
Yeah, sure. So I'm the founder and CEO of QuantMate. We are developing agentic strategies for trading. And besides that, I'm the author of several technology books with O'Reilly Media and Manning, and also teaching for Pact and O'Reilly in that space.
I'm Graham Sills. I helped found a legal AI company. We have a product that, think of it like the legal brain of an organization. It tries to do everything your general counsel does. So that's reviewing contracts, automating workflows, answering questions about scenario analyses, all that sort of thing.
Daniel Hume. I've been involved in AI for about 25 years, where I'm now entrepreneur in residence at UCL. I started the company about 18 years ago. It's been building AI solutions for the biggest companies in the world. I sold it to WPP, the biggest marketing company in the world, 4 years ago, and I run AI across about 100,000 people. I think WPP unofficially is the biggest user of generative AI in the world, and I get to invest and start companies. I just started a company to solve machine consciousness.
Wow, that was a fast one. So Peter Hill, the CTO of Synthesia. We effectively, for 65,000 businesses, about 90% of the Fortune 100 create training material through AI avatars. And for the most part, where we're heading, and I guess where the discussion of this one will be, is a new feature we call Video Agent. When we think about the Video Agent, it's a ability to have a real-time dynamic two-way conversation, for really training and reinforcement purposes.
Fantastic. So great. I think we'll start off with a wide lens, and I think I'll start with Nicole, because Nicole, with the work you're doing with O'Reilly, the book that you're publishing, you have interesting expertise in the area. So I just want to ask, to start us, narrowing from this kind of buzzword of generative AI, how do you define an AI agent, and what is distinctive about this, maybe compared to a chatbot or to generative AI more broadly?
So one thing I think what a little bit of a problem right now is called the term it's called for is agent washing. So putting just agent or agentic AI on literally everything. So everything is an agent, even if it's just a simple LLM, a static one, just maybe using tool, not even have memory or anything like that. So I think this is really a huge problem. So going beyond all that buzz. And also a problem, what I see from practitioners or people trying to actually use a agentic AI or move beyond that static and more in refining an autonomous system, is that this is also new, that there are no real sources in helping. So this was kind of a feedback I've got when I announced that I'm writing that book for O'Reilly about agents, and actually go beyond that hype, go beyond what agents are. And one of the first things I actually do is I demystify what an agent is. So to your question, Clark said any sophisticated technology is indistinguishable from magic. But what I do, and the first pages of one of the chapters of that AI book, is they are not magic, they are engineered systems. And this is really what we should think about it. So what I do is I compare them with finite state machines, because they still have a finite vocabulary. So they have tools. We give them tools. We give them a spectrum how they can interact. So they are not fully autonomous. They have a certain range they can operate. they don't go wildly off the rails if you orchestrate it properly with human in the loop patterns. So there are different things how you can think about an agent or semi-autonomous system, because they cannot refine their code themselves. They can't just reroute and rewrite. Like I use LangGraph as a framework, for instance, for developing my agents. So they just don't start out of themselves in generating new codes and rerouting the decision making. So you right now, even if you have multi-agent systems, they are still routing the decisions between the different agents with different tasks and different tools they've been given, and they orchestrate and operate in exactly that space.
Great. And to be concrete, I'm curious for your particular application for QuantMate, because you work in the financial space. Could you say, what is the task being solved autonomously? Are these agents conducting trades? Where are they given this kind of unsupervised reign to do their agentic work?
So they are specifically giving that autonomous part or semi-autonomous part in refining themselves. Is they get the strategies, they get the or existing strategies from clients, and they can iterate and refine the code based on this, and they do this in steps. And you can think about this fairly similar how genetics works. So you can think of those strategies as the parents of the child strategies and improving. So you have the genotypes, the phenotypes, so how something supposed to look, and then how it looks for genetics, and we apply those descriptors to the strategies and help then the customers to refine it. And this is done by feedback from the market, so from paper trading, from back testing, and also from the interaction with the portfolio manager, with clients, so to get the feedback. And this is how this, in that kind of setup, it's not fully autonomous, but it's always guided by the feedback by experts.
Great, thank you. And just maybe to give some broader coverage across different sectors, because we have this great diverse panel of specific industry applications. Maybe I'll go to Peter with the video agent. Can you tell me a bit about the autonomous task there and how you frame that for the users of the product? What is the kind of space of actions?
Yeah, definitely. So when we think about that, the actual agent itself, its intent, like there's two customers this, and we are remarkably customer focused. And when you think about the customers in this, there's a content creator. So part of the autonomous portion of this is there's a corpus of content. We believe very, very strongly there's like the notion of AI slop. Any AI can put out a lot of content, and that's not necessarily valuable. So part of the autonomous pieces are being able to take that content, understand that content, have it be the corpus of corporate content that you really want to teach, understand the goals, and then one of the first autonomous parts is having a conversation. So this is an agent where you can actually have an ongoing conversation with it. And if you kind of think about a real world example, think of like a salesperson. The salesperson, their livelihood is on the line when they're actually talking with somebody and trying to talk about the details of what they're trying to sell. In this simple example, you can imagine that the first few times where you're trying to talk about either a new concept or you're new to this role, like that's incredibly difficult. And you literally, the churn is super high for those types of employees. It's really hard for them to find success. To be able to have an automatic, ongoing, effectively tutor at any point in time where you can converse with regularly, where you can have that conversation, where you don't necessarily feel unintelligent in front of your boss as you continue to ask questions, as you continue to try to find mastery of this content. And so that's something where we found just an incredible ability for AI to be able to take the content you have, the goals which you're trying to achieve, and automatically, dynamically create the conversation that any one of the employees can have. So from the generation standpoint, the other part of autonomy that's very, very interesting is our approach into this is more of a prompted input. And so when you think about that, it's the second customer, the actual creator of this content. This person doesn't necessarily always know how to construct an agent or construct their content. They might just be the person that's most knowledgeable, that's trying to change the team. So often there'll be a manager, or that could be someone who is the subject matter expert. that subject matter expert doesn't necessarily know, teaching theory. They don't know learning theory. They don't know how to do this in reinforcement patterns or any of those types of things. So the other piece that's automatic is to be able to understand and apply known proven learning theory into how you're going to present that content, understand what the core concepts are, and then to be able to figure out where there's deficiency or where there's things that don't necessarily make sense to that employee, and then to be able to create adjacent, more micro learning moments. And you can imagine a practical example of that being something like, a Teams message or a Slack message saying you didn't understand necessarily this portion. We're now we're going to ask you very specific questions. And so you get a broad view of the mastery of your entire base of employees, and it doesn't necessarily have to be punitive. You actually just start understanding that these are training moments and that you actually have effectively a tutor. There's a great book, I don't know how accurate it is, so it's, probably shouldn't say it, but there's a great book that describes why are there not more Einsteins? And the thesis of that is effectively that there's not enough tutors. There's not enough specified learning. And so one of the things that we're really focused on, one of the things, I truly believe in, is that the more specific catered learning to this individual, the better it'll be. And the last thing I would poke at for autonomy in our particular space is that a person's pattern of learning will all be different. We're all going to learn very differently. One of the things that the agent allows us to do dynamically is to understand what has worked best for this individual when you're looking at the historical ability for this person to learn and retain fact, and to apply that to them specifically moving forward. And that might be and will be most likely different for another individual.
That's great. Yeah, thank you. I want to get Daniel as well to chime in on this from the context of WPP and think about how you frame this agentic autonomy, how you think about how these agents operate in the context of communications, branding, marketing. Do you give them their own brand voice? How do you interface with your clients and customers and kind of pose that collaborative environment to them to make adoption work?
Okay, so in WP we have a dual strategy when building agents. We have a self-serve model, allowing people to build their own agents that do stuff. And then we have where we know that those agents are not capable of doing their job, it goes into an agent governance process where we have to figure out how to build it, make sure it's safe, all that kind of stuff. So for the most part, the agents that in the self-serve model that people are building are things that human beings are interacting with. Argue they're not agents, but according, there's lots of different definitions out there. Actually, when we think about agents, so you can imagine trying to draw parallels with, I've never said this out loud, so it could come across wrong, but imagine drawing parallels with the robotic world. If I could build an arm that does a very, very specific thing every single day, and it's constrained by those constraints. That's just automation. It doesn't have any general ability to go out there and change its behavior. But imagine a humanoid robot that has been given a goal, a task, maybe to go and cook a meal. To be able to cook a meal, you have to go and solve lots of complex problems and go and figure out what problems it actually needs to solve itself. And that's really how we think about agents. Agents have a goal, that have the ability to have agency, so make decisions, but also have general ability to go and go off script. And so the problem with building agents that go off script is they can go wrong, which is why you're doing a PA postdoc in this. And actually, I would argue that most LLMs right now are like intoxicated graduates, right? And so what's happening and going to happen over the next few years is that companies are going to get very excited about agents, including WPP, and they're going to deploy an army of intoxicated graduates across their organization. And it's going to be, forgive the technical term, a shit show. And so people are going to realize that building software is not trivial. 80% of the cost of deploying software is testing. And people are not going to spend 8% of their time testing. So what's going to happen is people are going to deploy these technologies. It's going to go wrong. More emphasis on verification, evaluation, testing. So the self-serve model is actually allowing people to create agents in that safe place where we know if they go wrong, it's not going to cause mass harm. The other part of our organization is building agents where we have to turn it we have to turn it from an intoxicated graduate into an expert. Let me give you an example. So one of the challenges that we have is how do you create brand-specific production-grade content? So we create ads. And if you go to an LLM and ask it to create an ad for you, it's going to not get your fonts and your colors right, even if you tell it to. So even just asking a really good prompt won't get you to a good ad. The second way of making an intoxicated graduate smart is by giving it your brand guidelines, your tone of voice, your written copy. You ask it to create an ad, and just like an intoxicated graduate, it'll give you an ad that's 50% good. Most of the agents that people are building are only as good as what an intoxicated graduate will give you. The third way of making a brain smart or an agent smart is turning that into an expert. Now, we know how long it takes humans to become experts. It takes years of trial and error, training, blood, sweat, tears. In the AI world, there are only some models that you can actually turn into experts, and that it takes months to do that. Okay, so and that's what people realize over the next few years. When we build brand brains in WPP, we take an agentic approach. So this is for me the real power of agents. You build an expert at your written copy, your tone of voice, your brand guidelines, your imagery, your company values. Just like in the real world, you have a table of experts, agents that collaborate and communicate to get to an answer greater than the sum of the parts. The power of agents is not real agency. The power for me of agents is multi-agent reasoning, getting these things to collaborate with human beings as well and each other to come up with solutions greater than the sum of the parts. And again, building those systems is extremely hard.
Great. Daniel, I appreciate your faith in my future job prospects. It's very nice. And this is green tea, by the way, for the record. Great. Graham, we had a conversation earlier, just before this panel, talking about Luminance obviously operates in a legal AI context, and you use the term value per token. You work in a kind of a high value per token context. So I'm curious how you conceptualize, assistance workflows versus fully agentic workflows in the particular setting of legal and what you meant by that term.
Yeah, sure. So firstly, just quickly come back to some of the points that have been made. I think we try and get around the definition problem by actually also defining subagents. So subagents are your very constrained single AIs that are trained to do a certain thing. That might be a smart prompt, it might be a database query, it might be a web search. And that allows us to then go on to define the agency, the proper agent, which is, it understands the request it's been given, hopefully not in an intoxicated way, and can pick the right tools that it can trust. It knows they're very good at doing the single task. It can pick the right tools, reason, put them together in the right order to come back with an answer, and sometimes go around that loop several times to make sure it's got things right. But yeah, you're right. So the legal industry is one with perhaps the highest value to token ratio. One word can mean millions. So I guess, yeah, we put a lot of effort into making our agents very trustworthy, very reliable. We have something called a panel of judges. So this is legal term taken. It kind of means mixture of experts, but it's put in a legal sense because you can think of the Supreme Court. In the Supreme Court, you have 9 judges, and if one of them is intoxicated one morning and hallucinates, you'd hope that the other 8 will put them right. And the consensus is, obviously it's probabilistic internally, but that consensus is able to be more reliable, hopefully without any hallucination, and also more accurate, because we can pick and choose who sits on that panel, whether it's an LLM, whether it's a fine-tuned model, whether it's something we've trained from scratch, whether it's an embedding model or whatever, and we can pick and choose them for their strengths and weaknesses, and that allows us to kind of build that trust. So that answers the question.
Yeah, that's helpful. I think it's a good segue into some of the more particularities of orchestration and kind of how your domain environment kind of dictates how you want to set the agents up. So maybe I'll go to Nicole for the analog in finance. You've talked already about the agentic strategy evolution that your agents bring, the inspiration drawn from genetic algorithms. Is that also, is it good to understand that as a multi-agent setting, or how does your kind of orchestration architecture relate to kind of the multi-agent things that other panelists have talked about before?
Oh, no, I totally agree in having multi-agent systems. So this is also what I usually address when I was talking in the past on the panels or giving lectures about this. So the beauty of having multi-agent systems is really what you can do is you can break it down. So you have in computer science the divide and conquer approach. So this is the same what you do with your agents. So you can't think of an LLM, even if it's a reasoning model behind there, that it's able to grasp a very complicated prompt with several interchained tasks it should do. And also, if you think about the whole setup in a production environment. So one thing I was mentioning when I gave a book announcement was that I will guide them also through in not bankrupting the company, because if you give all or if you have like a multi-agent system, let's say just have an even number 10 agents in that multi-agent system, and everyone is a reasoning model, and it spins around and does and goes back and forth, then one point is you never get the answer because the latency will kill you. The clients will be annoyed because they don't want to wait that long. And the other thing is, you mentioned this already, like probably training. So what I always say is like, use small models and fine tune them on specific tasks. So they are really good. You don't need to have a billion parameter model. There was just a couple of months ago was a next iteration over the classic BERT model. So what they did is they created modern BERT with a rope extension, so it has a long context. Flash attention was implemented, so the latency is good, so it's really fast. And it comes in two sizes. So base is 145 million parameters and 270 for the large. And it's quick. I trained it on classification, on pro-social behavior, and it's really fast and it's efficient. So if you plug this into the whole system or Meta for an instance in having specialized models. So what they did is with their Purple Llama suite is they used an 86 million parameter model for classifying toxic prompts. So this is how you set up your specialized agents, your whole multi-agent system. So you have smaller parts. And another point for what's really important, if you orchestrate your multi-agent systems, and also what we do is you need to be very specific for a task. So you can't tell your large language model agent or a large language model who should analyze, like, I don't know, financial data, that it's a pirate and it's good about analyzing data. So there's a mismatch. So you need to be very specific and kind of anthropomorphizing the base LLM beneath that agent, so it gets really into that task. So this is how we set it up. So we have it very targeted, specialized, and we only use the larger models and the reasoning, and then even the thinking budgets, how they iterate over a task and how we control it.
Great, amazing. Two things in that response that I want to drill down into. You mentioned starting to talk about aspects of ROI and efficiency when you were deploying these agentic systems, but you also were talking a bit about modality. So did you want to quickly jump in on that?
What do you mean specifically? So for the modality or? On
modality, the difference between these fast flash attention classification systems that fulfill these kind of narrow AI use cases versus maybe more like semantically context sensitive agents with more of a larger, denser model, or
if you think about it, so you can train or most models are still very good if you have a specific task. For instance, there are different kind of architectures. So we have the encoder, decoder only, the embedding models, the mixer of experts. And I feel like one of the challenges or the problems right now is that some people still think they need to have that autoregressive approach for every setup, which is actually not true. So an encoder only model is very good in getting the semantics. So for named entity recognition, for classification, these are good models. You don't necessarily want that autoregressive model feeding back the things into the chain and into the loop in itself. You want that what it can reason back and forth, between that. So this is kind of what you need to think about, besides being more efficient because they are smaller and being faster. And I think like this kind of modality. So this is also why I'm coming from the perspective of saying you have finite state machines, because if you think about your system, that you engineer it, you think differently how you actually engineer your multi-agent system. So you think to take that step back, and this is what I try to encourage people: take a step back, think what kind of team member it would be, what kind of skills you would hire for, and then take this knowledge and think about how you can map this to the kind of personality of the agent and what language model would fulfill this skill the best.
I would echo that as well. I mean, so the right tool for the right part of the process. Actually, there is probably a place for some generalist models somewhere. They're actually very good at the human AI interface. Sometimes the smaller models will put things in a not very sort of user-friendly way, and you want something to assimilate that. And I wouldn't take anything away from the sort of simple chatbot as well. We actually, I mean, it's at Luminance, that's a very important part of our product. We imagine if you have your general counsel, your lawyer, a lot of what that person is there for is to go and ask questions. You know, how does Trump's tariffs affect my business? That 10 years ago would have been a research project for someone for a week, particularly if it's over 1,000 documents. Now you can ask that in a chatbot in Luminance. Okay, the first part is understanding that question and understanding which tools to call. But then that's a very important and complex agentic thing that has to go off and ask various different questions of databases to work out which documents it needs. Maybe there's some RAG in there, maybe there's some other techniques. So that's actually a really important agentic function.
Yeah, good. I'd actually love to get Peter's take on this kind of modality question when we're talking, because as I understand it, your product at least has the heaviest use of the multimodal video generation setting, which is a very high bandwidth domain. And I'm curious how your team thinks about balancing latency and quality there, given that you want to avoid visual hallucinations, grounding problems, all of the difficulties with serving fast and low latency video.
Yeah, I mean, in the video space, I think anytime you have a glitch, a technical term, of course, you do have hallucination, people lose trust really quickly. That's where a tool will quickly fall out of favor, and people will not feel that's going to be accurate. So when you think about our latency, it is something that it is a human-to-human conversation, and the value of this is it's going to be a longer human-human conversation covering multiple topics. So when we think about latency, we think about it from several different angles. From the creator standpoint, it's time to value. How can you actually get the amount of coursework and the lessons in the most succinct amount of time to be able to create something that's truly meaningful and will truly kind of advance the user. From the user's perspective, that conversation is probably not going to be their favorite thing to do. So it has to be engaging. It has to be fast. Anytime you have like the classic 1 second latency, or where the avatar is like, oh, let me think about that for a moment, which is common delay tactics. Those types of things just will cause the churn and move on to another tool. So for ours, it has to be effectively a trustworthy member of the team. When you think about the creation of the video artifact of that, there's going to be diffusion transformer type of approaches that'll keep it accurate and make sure that you're not drifting off into other types of graphical errors. But the conversation itself, I completely agree that you need to have, if you have a very narrow purpose, have a narrow data set, have a narrow LM that really focuses on that specific purpose. I think anytime you do go to the generalized models, you just have to understand the trade-offs, what they're good at, what they're not, and effectively how they're also assigning value to a response. Many are going to find that having a response, whether it's accurate or not, will be scored higher in their own rubric than not having an answer or providing a potentially incorrect answer. And so when you kind of think about like the pros and cons of each one of the tools, you just really have to understand them in detail. So for us, as we think about learning, anytime you do hallucinate or go off track with a customer's data, that is a trust buster. So we keep the data incredibly tight. You train and you build your models off that essentially, and build in a number of reinforcement mechanisms. Those reinforcement mechanisms will go down a few different paths. Obviously, inputs of the data, that's a human process. So that's where you follow more moderation. Where you start getting into more the automated ones, that's where you're going to start trying to figure out, can we look at the data? Can we understand who created the data? And so you're doing more of the tracking of the individuals to understand who the humans in the loop are. When you look at the actual data being processed, you're looking for statistical anomalies, anything that falls outside of your trends. And so for us, the defense and the hallucinations is not a singular thing, it's in layers. And so for us, latency is absolutely critical. Most of the human conversations you're gonna find, vary on different humans, different cultures, but some studies will put it at roughly, humans are starting to create a response, generally around 60% through the other person's sentence. And so there's a lot of things you can learn to how humans interact as well to be able to play with that latency. CPUs are very good at finding predictive models. You look at branching logic to be able to understand and via probabilities where this conversation could be going. That gives you a lot of opportunity, and that's where we focus right now to try to figure out, can we guess what this conversation is doing? Can we actually hide some of this latency because we care so critically about latency, to try to really get that down to probably around the 50 millisecond range. Some of the models in conversations are well over a second, and that's frustrating. And that's not something you're going to do over time. That's not something where you're going to have an engaging 5-minute conversation on. And if we're truly trying to change learning, and the corporate use case, I think it's broad, but obviously it can be much broader beyond those use cases. Latency is fundamental. Latency and accuracy is paramount, and so we're going to do everything we can to drill down and make it human-like.
Yeah, this is good. I'm glad that you're kind of taking this partially in terms of observability and quality measures for the product, because given this is a more intelligent tool than you might be used to with traditional business logic, that you're trying to version and do incremental improvement and quantify the user experience. Curious for how you kind of run that internally at the team, as far as understanding how incremental changes or improvements have made the user experience better, or when you need to roll back, or how do you maintain observability with this product?
Admittedly, the foundations that we stand upon seem to change weekly. So as we're building these things, I think one of the things that we realize is that there's clear buy versus build decisions, and there's clear technology decisions that you have to make that actually lead to large trade-offs. It's incredibly difficult to understand what will be stable in the AI world over the course of a year. And so you really have to be careful with your bets, build off build the right abstractions to be able to understand and realize where you believe there will be stability and where there won't, or where you have strategic advantage. So as we do this, it's in an incredibly iterative process, and it's a very layered process. So when we look at some of the basic ones, the accuracy, and any time we veer from what we deem is accurate, and we have another agent that will look and try to measure that accuracy, that is something that we care deeply about. That's one of our core metrics. Latency is actually secondary to accuracy. And so for the hallucination, that's our primary, because if you don't trust this device, if you don't trust the answers, you don't trust what is being taught at scale, you will certainly not use it. Latency kind of falls into the second. And that's something that seems very easy to measure, but it's actually not, because the human-to-human conversation is not, I guess, often as clean handoffs as we have today. Like most human conversations are partway through a sentence. And so that latency metric is a little bit different. As we've started to tease apart what seemingly would be a simple gap between one speaker and the next, it turns out to be far more complex than that. So the latency piece, we're still learning and iterating fast, but so it's a layered approach, looking at accuracy, looking at latency, then retention and understanding how effective are we is kind of the last piece. And how do you actually condense the amount of time it's going to take for someone to learn a topic? And so as you think about that very, very broadly, that's where we're actually just doing simple A/B testing. You have on an individual, they all, like I mentioned before, they're going to learn differently. But even within that individual context, there's room for A/B testing to be able to understand this person. Maybe they're more of a visual learner. Maybe they're more,
if I liked your brain analogy. If you think about like the hippocampus and its ability to kind of take, a visual artifact and make an association with content as a memory mechanism. Like, I think those things are things you just have to understand as you're building these models to be able to associate. If we showed a video or a graphical component next to a textual component, is that going to change the way that someone learns? And so from the effectiveness of that, it's actually remarkable. There's so many things, and there's so many studies. I think one of the things that AI has, or the tech world has not done well, that I'm very excited about, is that in education, there are so many real studies that actually talk about how people learn, and they're incredibly effective, and they're just not leveraged. And so for us, like, it's how do you take that that body of work, and apply it? And so we have multiple measures, and first is your experience, and it's kind of effectiveness.
Awesome. Yeah, I do want to shift to Daniel on the same question or area. In the context of marketing, how do you think about, given that I'd anticipate the needs of different customers in your case can be different. I'm curious how you find signal from that, how you are also kind of building for observability and incremental improvement.
So I've talked a little bit about brand brains and why it's important to create a council of experts, and each one of those experts have different modalities, imagery or text, and each one are trained differently. Some might be RAG'd, which you just give it some information. Some might have to be fine-tuned. Others might have to. So even those different experts are trained and tuned differently. When it comes to, so once you've got a system that can create content, your next challenge is how do you understand how people perceive content? And for the first time ever, we can build brains that recreate how people think and feel about things. Historically, if I show you an ad or a policy or some promotion material, I didn't know what goes on in your mind and body unless I ask you. People are not very good at reporting on what goes in their mind and body. So for the first time ever, we can build brains that we call audience brains that recreate how people think and feel about things. And actually, unlike brand brains, where you have to the complexity is how you pipeline these different technologies together, really the way you build audience brains is data. Do you have the data that represents how the audience perceives something? So historically in marketing, there's been an impulse to collect people's names, addresses, dates of birth, gender. Where you live and how old you are is a proxy for how you're going to perceive something. It's a crude proxy. How you perceive an ad will depend on the time of the day, whether you just had coffee, how well your football team played at the weekend, whether you've just fallen in love. Understanding the data that you need to build representative audiences is the differentiator in that particular case. And what's interesting, going back to this idea of judges, you can build brains that don't just represent target audiences who you're selling to or whatever. You can build brains that represent every corner of society, from political parties to newspapers to, minority groups to even legal frameworks like ad claims or sustainability claims. And so when we're creating content across our supply chain, we actually show it to this council. We call it a council of representative AIs, to ensure that we're not triggering any communities, breaking any laws, or causing any harm. Now the question is, how do you make sure that those representatives are actually representing that audience? And that requires surveys and all that kind of stuff. And maybe just one thing to mention, I know I have described to them as being intoxicated graduates. I think it's important to understand that they are moving to a master's level, so they can do rudimentary reasoning. And there's an important aspect here to understand when it comes to reasoning. If I tell you that Socrates is a man and that all men are mortal, I can infer that Socrates is mortal. Now, intoxicated graduates can't make that inference unless it has the data. Master's levels can make those inferences. The complexity is going to be is if you're sort of semi-certain that Socrates is a man and only a little bit certain that all men are mortal, how do you make that inference? What's the probability of Socrates being mortal? And that's some of the complexities around multi-agent reasoning. The nice thing about audiences, so each audience that we build has knowledge about itself and the world. And the nice thing about audiences, you can get them communicating with each other to try to infer new knowledge. And we have to do that very carefully, because you end up, if you're inferring the wrong knowledge, you end up propagating and poisoning the data. So there's lots of really interesting problems we need to solve. And just to finally mention that we are moving from master's level to now PhD level, so you can give it a very complex problem. I think in the next 2 years we'll have a postdoc level, so somebody can do science, and by the end of this decade we'll have a postdoc we'll have a professor in our pocket, and that professor will not only be able to solve hard problems, it'll be able to actually come up with questions that humanity hasn't come up with. So when we talk about building technology, we build to that timeline. as opposed to building where the technology is now. And just one thing to mention about latency and all that kind of stuff. We all know that large language models are horrendously energy inefficient. They learn very slowly. They require loads of data to learn. Your brain operates on the power of a light bulb. You learn very quickly. I only have to say that's a cup to you once before you know what cups are. You only have to see something once to know what it is. You don't have to see millions of examples. There are many innovations that are coming out of academia that are going to allow us to build much, like thousands of times more energy efficient, more adaptable AIs. And that's going to change the landscape over the next 5 years. So just make sure you're not building technologies for now, build it for the future.
This is, great segue, because I want to give everyone on the panel one more chance to speak on this, the 5-year horizon, maybe the 2-year horizon for some of us, before we jump to audience questions. So maybe Graham, in the legal context, if there are professors in our pockets in 5 years, will we still need human lawyers? Where do you see the
Well, I mean, firstly, there's so much I could say about this, but I don't think they'll be in our pockets. I think, some of the advances in wearables at the moment, things like the Apple AirPod 3s, things like that, that's going to be, I think, one of the ways we interact with AI. I don't think society is ready for thought reading, Neuralink type things yet, but I think something a little bit more closer than the kind of the AI that we have in our pocket already. But yes, you ask whether we need lawyers in 5 years. Well, that's a question I get asked a lot. So I think we're in an information revolution, but it's not the first time we've been in one of those. There's loads of analogies from history. I like the one of the printing press, where Johannes Gutenberg 600 years ago thought he would undercut the industry of hand painting Bibles by inventing the printing press. And overnight, the price of producing a book fell by, they reckon, about 300 times. So we're in an industry now in the legal space where the cost of understanding a contract is plummeting in a similar way. You no longer need to have trained for 10 years to understand a contract. So that brings us to something called Jevons paradox, which is where the cost of processing is dropping so much that, does it mean we don't need as many humans to do the work? In other words, one lawyer could do the job of 100, or does it mean we're going to get hundreds of times more legal work to do? And so it's probably going to be a bit of both. I think maybe the number of lawyers will go down slightly, but there will be a load of benefits as well for society. So the first is that ordinary people will be able to afford legal advice. At the moment, it's in the realm of rich people and companies. But actually, if you're wanting to check your rental agreement for the house you've just trying to rent, you're not going to go to a lawyer at the moment. You might pay $5 to upload it to a website and be told with reasonable confidence that you're not at risk. That sort of thing will, this is something Professor Webb was talking about in one of the earlier sessions, that there's a lot of kind of places in the world where we could take law. So that's one thing, but also the lawyers themselves, I think, can go on to much more strategic work. Instead of just being paid for their time, being really bored reading contracts all day, they can focus on the strategic work, the actual outcome-based work. And that's, we're seeing amongst our customers, we get feedback saying, this is really helping retention of our employees, because you're taking away some of the boring work. You're actually giving us an interesting thing to learn about AI in our workplace. And it's allowing them to focus on what they were actually trained to do rather than reading. And then I think also, we don't know what jobs are going to be like in the future. There will be a change, definitely. But I think some of the skills we will need are actually the skills that lawyers will have. We're going to have whole new economics, whole new laws that we're going to need to cope with AI and the bias and the prejudice that it'll uncover, and some of the surveillance and control issues that we'll have. We're going to need humans to make up those laws. We don't want the AI to do that. And the other thing is encoding into the AI, into the prompts, all of the ethical rights and wrongs, all those philosophy essays that people at Oxford are probably thinking about at the moment, not coming to a conclusion, perhaps, weighing up each side of the argument. We're going to have to actually answer some of those questions and encode them into the AI to make sure that it stays ethical. So I think there's a lot of hope for the legal industry, as well as maybe a few people not having to do such boring work. Right. Nicole, what does the future hold?
So I don't know, some of you might know Ray Kurzweil from his book about singularity. And maybe something lesser known is what he stated about the law of accelerating returns, which basically means that the current technology builds upon the previous one, and it speeds up, and we just conceive it differently because we mostly conceive it linearly. I feel like we are in that extreme accelerating part, because now we have the hardware, which is already like extremely capable. And some of you might know Grace Hopper. She deserved even get a GPU named after her. She was walking around with that wires in telling people than they told her back in the days when she was a computer science or programmer, that she needs to speed up things so that the speed of light just travels so far in that amount of time. So now we are here and it accelerated faster. And so what we have right now with the agentic AI was just a very logical step in the whole like development. If you think about it, so when we had deep learning and we had all those AI winters and things in the development starting in the 1950s, that in the 1990s, LSTMs and deep learning CNNs came up, and it was all still very slowly. And if you think about it, 2017, attention is all you need. And where we are right now, we see how fast all accelerates right now with the hardware at our fingertips, how the technology is perceived. Also, what is unprecedented is that directly, like humans interact knowingly with AI. It was not knowingly done so in that specific way previously, like Netflix and all the others used algorithm to improve recommendation, but the customers weren't so aware about. I think like this all gives to the speed up, and in terms of in the pocket, actually things are already like moving in that direction. So there are papers or experiments. So some of you might know ICLR, which is one of the most prestigious machine learning conference. And there was done an experiment from AI researchers in actually using agentic AI in submitting papers to workshops, and they got approved. So this is where we are right now. So
that lab.
I think there'll be a meaningful kind of development to science in the next year. Yeah. I think there's already small ones that have come about. One of the papers that I think really went under the radar this year is actually that off-the-shelf generative AI has been used to get gold medals at the Olympiads for maths and computer science. And I mean, that amazes me. So, I mean, yeah, I think there's going to be more and more of that.
Yeah, the work on the AI scientist was done in a lab here at Oxford in collaboration with Japan, the Forrester Lab in engineering. Yeah, it's the worst it'll ever be from now on. Maybe, quick points. I want to hear from Peter and Daniel on this topic. Anything else to add on the kind of the future horizon, and then I'll open to audience questions.
No, I think what's been said has been spot on. The only thing I would add to that is, if you kind of look historically through phases, like it feels like this is kind of one of those industrial revolution moments, where I think you see a lot of the broad kind of like repeatable tasks being managed by automation. And I think the interesting part in my observation, at least for our line work, is that what it really has meant is specialization. And so it meant that there's not fewer in end count. The initial worry was that, does this mean junior engineers go away? Does this mean that all the rudimentary work disappears? Could happen. But right now the observation is instead that what it means is that Cursor and the likes of those tools mean that the generalized, very repeatable things like an industrial revolution are now just automated. And so it really means that the folks that we have coming out of school are actually working on meaningful, unique, tasks that are, challenging them. And so I think what you generally see is this more specialization happening, in many more trends, in many more areas. For us, we think that's, probably attractive, because what it means is that humans are going to need to continue to learn, and you're going to need to learn at greater depths. You're going to continue to find more specialization. And we hope as you start seeing more of these types of specialists, more depth and understanding, you're going to see even further innovation, coming from the human counterpart to the technology. I think that what you generally find is as people start gaining mastery in an area, that's where, the innovation, that's where the, improbable thoughts start coming in. And that's where we start seeing, new waves and new innovations. And so for me, obviously there's some trepidation, like we don't know what we don't know, but for the most part, observably, it really means that humans are going to get deeper into more narrow spaces, and to be able to really, really focus in ways that they haven't been able to in the past, because I think we've, as humans, have been pushed to more generalization at the earlier ranks.
I think there's going to be a massive amount of misinvestment from companies placing the wrong bets over the next several years. There's that phrase, what is the futures here is just not evenly distributed. And I think that unfortunately is going to be even more extreme, because there's going to be a massive amount of misinvestment. I think there's going to be a handful of companies that really understand how to architect themselves for these technologies. I think there's going to be a Cambrian explosion of startups that are leveraging these technologies to beat the 99% of them that do misinvestments. And I think the technologies are going to kind of continue to evolve exponentially. So we will see some scientific breakthroughs. I think beyond 5 years, nobody knows what they're talking about. And I actually argue that there are 7 singularities. I won't bore you with them right now, but one of the singularities is one of them is coined by a very good friend of mine called Callum Chase. He coined this economic singularity, which is the point in time when we automate the majority of human labor. And I guess the 2 extremes of the argument here is that when we can free up whole jobs, we probably will. Right? When these AIs can take the capitalistic model to reduce costs, increase profits, means we'll free up. If that happens very quickly, we stop hiring, etc., we could then have mass technological employment. Our economies won't be able to rebalance, and it'll lead to social unrest. And I think that we really need to solve that problem. I think UBI, 4-day working week, we need some mechanisms to take the edge off that. The counter argument to this is that by removing friction, which usually means human labor, from the creation and dissemination of goods, you can bring the cost of goods down to zero. So imagine being born into a world where you don't have access to paid work, but everything you need to survive and thrive as a human is free. Your food, your healthcare, your education, your energy, transport, it's all free. So what would you do with your time if you were completely economically free? What would you do? Golf is usually the first answer I get. Fishing, yeah. And indulge in your hobbies, travel, spend time with your friends and family. What else would you do? Yeah, learn. What else? Yeah, most people's punchline is that you'll make the world. We want to make the world better. We'll all do those nice things, but we also want to make the world better. And I think we're all born into economic constraints, preventing us from what I would argue is living our true humanity, which is not just doing those nice things for ourselves, but actually trying to make the world better for everybody. There's a concept called protopia. It's not a utopia. It's a system that is incrementally getting better. If we can use AIs to free people from economic constraints, I believe those people will use their time and their energy to come up with innovations that are going to free other people from those economic constraints. And that's what the future that I want to create after 5 years.
Daniel, fantastic closer. Yeah.
We shouldn't be afraid of job losses. We should be afraid of the implications of job losses.
Fantastic. I have 8 minutes for audience Q&A. I'll try and keep it close, but we have a mic to pass around, so please. Yeah, go for it.
Hi, I am curious to know more about what are the tools, libraries, programming languages that you use to build your agentic systems?
Anyone who wants to take? Go for it.
Yeah, we're all over the map. And so for us, if we think about more of the agentic systems, one of our first decisions was a real-time model versus stacked model. And so when you think about kind of those models, they each come with their own implications. Real-time models more lock you into proprietary systems. If you're not, the stack models for most of the agentic systems, allow you to layer in more of your own custom technology, whether it be voices. So for us, we have chosen stack models at the moment. So in that stack model, if you look at 11 Labs, they produce a stack model. There's obviously OpenAI, they produce it, and there's more and more ones to choose from. So for the video component to that and the voice component to that, we have our own. So for us, the why we did that, in a buy versus build, why would you build your own voice? The actual accent preservation and the human preservation aspects of this are critically important to us. Because if you're actually trying to scale a human and teach as a human, and you have this digital representation of that person,
the North Americanization of the voices, I think, is kind of appalling a bit when you kind of look at it very broadly. So that's why we felt very, clear we need to have our own voice model. We need to have our own video model. When you look under the stack and then start, continuing down the layers, there's a huge amount of customization for our models. How do we actually, MCP is going to be the access layer that we're going to choose to, branch together all the different, components. It's a very, kind of simple AI-esque way connector mechanism. For us, one of the other big decisions is like, do we want this all local? Do you want it kind of in a cloud store? Because that is going to guide a lot of your decisions. There are some companies that are doing their own. If you look at some of the large language model companies, with the volume and cost of GPUs, they're starting to build their own. We're nowhere near that, so we're deeply into the cloud space. For code tools, if you look at like Windsurf, Cursor, all those tools, we're very heavy into those. Like we have a metric about how much AI tools each one of our engineers use, the kind of proliferation. It's not to say that they should or shouldn't. We just start gaining some statistics about how effective their production has been. The short story is Cursor almost always wins in our internal tests, and so beyond that, I think. It's per use case that ends up being, more interesting. So happy to kind of dive into any one of the general use cases, but that's kind of our overall stack model for the agentic portion.
Cool. I want to go to the next question. Speed. We have one.
Yeah, I have a question, probably a two-part question. First, in your experience in the context of deep agents, are you using prompt optimization, like with tools like VSPy? Secondly, have you been testing with self-improving agents, especially where there are failures and you're trying to create more synthetic data and add on that?
We absolutely we care deeply about the prompt itself. The most people that we have as customers aren't familiar with how to create an effective prompt. If you look at the OpenAI stats, one of their most common stats is create a better prompt that helps me answer the following. If you look at that pattern, that's hugely, massively common. So for us, it's more of a guided experience. And so for us to be able to understand what the intent of the person who's writing the prompt is a bit of an art that I haven't found solved in an elegant way yet. So for the most part, we're trying to understand all the dynamics that make critical sense, will make this content far more effective. And so for that part of the prompt engineering, yes, it's incredibly important to us. And we customize that through more of a guided experience at the moment rather than a raw open prompt.
I can give a slightly different perspective. I mean, we think instead of prompt optimization, it's more like context engineering. It's actually like how can you get all of the context that you need in one place? And that can be different dimensions of context. So obviously loads of people talk about context windows and how they increase and increase. It's not just about the walls of text that you put into your context. It's also, where you are, what time of day it is, what the state of your business is, who this customer is, what you're trying to do with, all of that context in one place is if anything, the most important bit. Then, how you structure your prompt, make sure you say at the end that end on a positive note and the prompt can do it, that sort of thing. But I think context engineering is the term of the day.
Yeah, one point I want to add is you might want to look into multi-turn conversations with human-in-the-loop patterns. So what you can actually do is you train specific models to interact in that way and help the user refine the prompt so you circumvent that problem that you don't run the whole system and have the whole costs coming for the task. So you see this with deep research UI. So they come up with some formalization, what they are going about to do, how they understood the task, and then you can modify. So if you go in that direction, you don't have to care so much about the prompt engineering itself. So you have a user putting in the query, then you have a conversation first with a specialized model, extracting the right knowledge, have it refined as a proper prompt, and then send it to the system. So this is how we approach it.
So using the human as an agent?
Sort of, yes.
Thank you.
Time for one last question. We have one?
I guess I have a microphone. I don't know if I can use it. Sorry. Okay, so I wanted to ask, we build agents for all sorts of companies as an agency, and all the craze seems to be like building these vertical systems. Like all of yours are basically vertical systems. There are the generalist stuff, and then you are going into something quite deep and getting very good in that. How much longevity you think these things have? Like, obviously, I'm selling the same thing. I'm not building an entire company around it, but yeah. And for the foreseeable future, I see that this will stay the trend. I mean, the generalist models are extremely unreliable at these kind of very hard tasks that you are solving. But how do you see it in 5 years? Let's say if a generic video generation model gets very good, do you still have a business then? I guess you probably do think about this. I'm really interested in, I mean, this is a question basic for everyone, but maybe especially for Synthesia.
Yeah, I'll start then. So actually, the video model itself is not the core of the business. What success is actually learning. And so if we can actually have someone learn, that is our goal. That's that's our metric that we're going to follow. If tomorrow there was an API that produced an avatar that didn't have 8-second limitations, that allowed for long form content learning, that actually met the criteria, we would swap to it, no problem. And so it's less about the generation of the avatar. And this is what I was briefly mentioning earlier. It's understanding where your strategic bets are, and then understanding where you want differentiation. And so for us, that differentiation and our strategic bet is on learning, and that is our core rubric. All of the other things are kind of means to that end. So video, it's really clear if you kind of look at the world, that the world is heading in a video-centric way, like a proliferation of TikTok. It's no surprise. So that is why we jumped on that aspect. But yeah, as I was mentioning, if that meant that we needed to use another API to achieve that, that would not be an issue. The brief comment I would have for like how I would think about your general question, the generalist small tools versus the functional deep tools, like the observation I have is like you see proliferation of the general ones almost as a fad really quickly, but my hunch is that you're going to want to go extremely deep and solve problems that are incredibly meaningful and lasting to a customer. And I would just, as a model, want the fastest iterations possible because you can't predict tomorrow. And so wanting to really gauge as many of the decisions you can and build that into the smallest incremental components and test that with your customers as absolutely fast as you can.
Great. I have to call it there, unfortunately, but please join me in thanking our fantastic panelists.